All right, this is going to be the video for the second half of 1.8 on inverse functions. What we did with the first video was we basically verified and proved if functions were inverses of each other through FOG and GOF, meaning it had to equal x. We also went over the basic point that inverse functions, you switch the x and the y charts. And we're really going to use that to find the inverse function. You can see I already have the 3 steps down on here, which you guys can take down right now in your notes. First step, you're always going to have an equation that's in function form. So just take the f of x and replace it with y. So you have a y and an x. Then the second step, this is really the whole basis, the informal definition. You want to switch the x and the y, and then you want to solve for the y. So really, kind of in essence, you're solving for the original x in the equation. All right, but the main step is this, switching the x and the y. Solving for y, that means you want to get y by itself. All right, let's look at the first example. Okay, first example, we have f of x equals 5 minus 3x over 2. So if I follow the directions, I'm replacing f of x with y. So then I can just write it as y equals 5 minus 3x over 2. Then second step, I switch the x and the y. So then it becomes x equals 5 minus 3y over 2. Okay, now I want to get rid of this. I want to get rid of the fraction. I want to get this y. I want to solve for it. So I want to get it by itself. First thing I'm going to do, I'm going to get rid of the fraction. I'm going to multiply both sides by 2. When I do that on the right side, these 2's cross cancel. Then I want to multiply this left side by 2. So then I have 2x equals 5 minus 3y. Then I just have 2 steps left. I'm going to get rid of this 5. It's positive, so I subtract it. So then I have 2x minus 5 equals negative 3y. Then the last thing I would do, I'm going to divide everything by negative 3, and I have that new y by itself. So then this equation here, I'm going to rewrite it. This is the inverse function of x equals 2x minus 5 over negative 3. So there it is. I followed all the 3 steps right there. Okay, I'm going to do the next one where you have the cube root. Save some space. I'm going to erase what I just did. So if you don't have it, make sure you can stop the video right now and take it down. All right. Okay, let's work with this second one here. So I have cube root of x plus 1. So I'm going to replace it with y equals cube root of x plus 1. Then I switch the x and the y, so I have x equals cube root of y plus 1. Okay, now if you want to get this y by itself, you have to get rid of the cube root. Well, the opposite of taking the cube root of something is cubing it. So we're going to cube both sides. So I'm going to cube the right, and then I'm going to cube this x. So this just becomes x cubed. The right side, the cube root goes away, and it's just y plus 1. Then you only have one step. You just subtract 1. And then we're going to have y equals x cubed minus 1. And then if I want to put this in function form, I can say this is the inverse of x, which is x cubed minus 1. Okay, let's do the next one. The next one is by far and away the hardest one on here, number 3. Because you see we have 2 x's, which when you switch them, it's going to turn out being 2 y's. Okay, let's erase what we have above it. Okay, can't do it. All right, so let's do this. I'm going to do this all in one step. I'm going to already switch the x and the y, so I'm going to have x equals... So I know f of x is y, but when I switch it, it's x. Then it's y minus 3 over y plus 2. Okay, now you're probably looking and say, well, how can I get y by itself when I have 2 y's? Well, it's kind of a proportion. Well, it is a proportion. I can say it's x over 1. Let's first cross multiply and set the cross products equal to each other. Then we'll take it from there. Okay, this is going to give me x times the quantity of y plus 2. I'm going to set that equal to the other cross product, which is just 1 times y minus 3, which is just y minus 3. Okay, then I'm going to, on the left side, I'm going to distribute the x. So when I do that, let's see here, it's xy. Then I have x times 2, which is plus 2x. Then this equals y minus 3. Again, you still might be thinking, all right, but we still have two i's. We have this y and we have this one. Okay, this is what you want to do. You want to get those two terms that have the y's by itself on one side. And then what you could do is you could factor out a y. All right, let's see what I mean here. I'm going to subtract y here, so it cancels out. I'm going to subtract y on that left side. So the left side of xy minus y. And then, now let's bring down the plus 2x. And then it just equals this negative 3. All right, I want to move this 2x over so that I just have these two terms of y's by itself. So we're going to subtract 2x. It cancels, subtract 2x. So then we have xy, see, I'll get sloppy here, minus y equals that negative 3 minus 2x. Now here's the key part. The reason why we got the two y terms by itself, I can factor a y out. So when I factor this y out, then on the inside I just have x minus 1. So that's your whole key. You want to factor a y out, so now you only have one y, not two y's anymore. And this is still negative 3 minus 2x. Okay, then all I have to do is it's y times x minus 1. Then I can just divide both sides by x minus 1. And we have it. So there it is. That's our inverse function. This new fraction, negative 3 minus 2x over x minus 1. This is probably a good one, to kind of look over a couple times since it is a lot more difficult than the first two. All right, let's see here. Let's do the last part here. This kind of goes back to vertical line test. There's the definition right there. Now this is horizontal line test, and well, why is this horizontal line test? Well, because it's the complete opposite. Since inverses, you switch x and y. If you want to find out if an inverse function or if an inverse equation is a function, you could look at the graph of f of x, and if no horizontal line intersects the graph at more than one point, then the graph of the inverse is a function. All right, I just felt like I was just yammering there. You might be saying, what are you talking about? Let's look at an example here. Hopefully we can figure out what all this means. All right, we have this right here, y equals x squared, and we want to find the inverse of it, and we want to figure out if that inverse equation is that a function. And we'll do it a couple ways. Let's find the inverse. Now, I don't have f of x, so I already have y. Let's switch it so it's x equals y squared. Then let's take the square root. I want to get y by itself, so I take the square root of both sides. Whoops. So then we have y equals, and then when I take the square root of this x, it becomes plus or minus square root of x. So that's the equation. Now this is what I'm going to do to figure out if this, here's the question, is this a function? Now here's one way we could look at it. This originally is f of x. Okay, I kind of left it out here. Now I know the x squared, that's just a parabola. Now if I use this horizontal line test, this fails it. Right? That passes it at 2 points. So the answer to this question is no. This equation here that we got, this y equals plus or minus root x, that's not a function because I looked at its inverse and that didn't pass the horizontal line test. Now, you could also look at this. If you graph this, we did this graph before, this positive root x is this, the negative root x is this, well, this fails the vertical line test. All right, so that's another way of looking at it. Okay, so if you want to just figure out if f of x, if that's inverse as a function, then you could just look at that graph of f of x. All right, and that's pretty much it. That finishes up 1.8, all of inverse functions.